Well, y'all, it's time to take and put some things together. We've been studying nomenclature, right? How to name and write chemical compounds. And I've told you in chemistry, it's all about electrons. It's all about reactions. We take two things, we put them together, and you get, this. Well, these are called chemical equations. And so now it's time for us to be able to take our knowledge of chemicals and put it together. What do I mean by? Well, let's do an example. So you're going to get a new packet. This is page 1, number 1, where it says word equations. It says zinc and lead 2 nitrates react. So zinc and lead 2 nitrate. React to form. Yeah, I'm kind of writing squished because I want to be able to fit it. Zinc nitrate and lead. Zinc nitrate and lead. Okay, so that's your equation. And now you need to be able to write the chemical formula that those words stands for. So here we go. Zinc, it's just Zn. Right? You've memorized that as an element. So it says zinc. The word "and" means a plus sign. Lead 2 nitrate. Well, lead is Pb. You have version +2 for lead 2. Nitrate is NO3. It carries a -1 charge. Therefore, I haven't written that properly, have I? Because these two charges don't cancel. This is an ionic compound, a metal and a non-metal, positive and a negatively charged thing. So, you put parentheses around it, you give yourself 2 nitrates, -1, -1, now your charge is canceled. Got to erase those just to keep things clean. Reacts to form. Whenever I see that, I write an arrow. It means to make, reacts to form, creates, I'm looking sick, combines to form. Sometimes you got to kind of read between the lines out, but usually I give you something. All right, so reacts to form, boom. You're going to make zinc nitrate. So zinc, Zn. It's +2. Why? Because we're memorizing it on that little sheet we have. Okay, that sheet we have where we're memorizing ions. Nitrate is NO3 with a -1 charge. Again, just like it was over here. Well, again, we end up with a situation where we need 2 zincs, 2 -1s to balance out the +2 of the zinc here. And P. Now, when we look at this, we have to ask ourselves, is it balanced? And what does balancing mean? Balancing means this. On the reactant side here, we have to have the exact same elements as we have here. Why? Because that's something called the law of conservation of mass. Lavoisier declared that for us, along with John Dalton. So we have 1 zinc here, 1 zinc here. 2 NO3s. If we can, we can keep them together. Otherwise, we got to break them into their pieces. But if we see NO3 on both sides, 2 of them, 2 of them. PB, there's 1 of them, 1 PB. Awesome. Let's do number 2 together. I don't know if I'll be able to fit this on the page. Probably got to move it around. So it says aluminum bromide. And I'm just going to go ahead and boom. Al is aluminum. Its charge is +3. Bromine is Br. Its charge is -1. Well, these two charges don't cancel each other out, do they? So therefore, I would need 3 of these -1 bromines to cancel the +3 of the aluminum. So the proper equation for that is AlBr3. The next word is and. The next thing is tricky. It says chlorine gas. Well, in class, I'm really going to hammer this, okay? The idea of this thing called a naturally occurring diatomic, meaning they don't ever exist by themselves. You notice, like, when you breathe in oxygen, you don't breathe in O, you breathe in O2. Why? Because it's a naturally occurring diatomic. Chlorine is a naturally occurring diatomic, so therefore, it's Cl2. It's unstable. It has 7 valence electrons. In order to fulfill its octet, we take one with 7 electrons, another one with 7 electrons, and then what they do is they share a pair of electrons. Why? Because that gives both of them 8 when they share. So, when we do this, it says aluminum bromide and chlorine gas reacts to form, so arrow. We make aluminum chloride. Well, Al is still +3 charged, and chlorine is -1 charged. Now, some of you guys are going to say to me, well, wait a minute, Mr. What about this back here? Nope, it's now bonded to a metal. This makes this ionic. Ionic things, when you take a metal and a non-metal, right, a positively charged thing and a negatively charged thing, now we transfer electrons instead of sharing. This was covalent. So that's why they're different. So we still need to make that charge thing happen. So therefore, -1 does not cancel +3. 3 -1 chlorines does cancel that. We get rid of the charges just to make things look a little bit cleaner. And is symbolized with a plus sign, and then again it says bromine gas. Well, just like chlorine, bromine by itself is also covalent, meaning it's got 7 valence electrons. It's looking to share them with someone else to get stable, to fulfill the octet rule. So therefore, bromine has 2 as well. So it's kind of weird for us to look at this and see 3 bromines here and 2, but that's because, again, this is ionic, and this is covalent. So, here we had to worry about the charges. Here we did not. Here we did. Here we did not. Now, the last thing we have to do is we do have to balance, because we can't have 3 bromines and 2 bromines. But we wrote the formulas correctly. So what we say is this. Counting by 3s and 2s, what is the first common number? It's 6. So 2 times 3 is 6 bromines. Well, 3 times 2 is 6 bromines. But when I fixed the bromines, I made myself an aluminum problem, because 2 times 1 aluminum is 2 aluminums. I only have 1 aluminum right here. Therefore, I put a 2 right there, that gives me 2 aluminums. Well, that also gives me 2 times 3 chlorines for 6. So I got a problem here, don't I? Because I only have 2 of them here. So I say to myself, okay, self, how do I get 6? I put a 3 right there. 3 times 2 is 6. So 2 aluminums, 2 aluminums. 2 times 3 is 6 bromines. 3 times 2 is 6 bromines. 3 times 2 is 6 chlorines. 2 times 3 is 6 chlorines. And it is a balanced chemical equation. Let's do one more. Number 3. Number 3 says sodium phosphate. So this is Na, carries a +1 charge. Phosphate is PO4 with a -3 charge. Well, therefore, it's going to take 3 +1 sodiums to cancel the -3 of the phosphate. So you get rid of your charges just to keep it clean, and that's how you write sodium phosphate. The word is an, so it's a plus sign. Calcium chloride. Calcium is Ca with a +2 charge. Chlorine, it's not all by itself, so you don't have to worry about that naturally during occurring diatomic thing. It's bonded to calcium, a metal. So it works as a nonmetal, therefore it carries a -1 charge. Well, it's going to take 2 of these -1 charges to cancel the +2. So you get rid of your charges. Reacts to form. This is called a double replacement reaction where we're going to switch partners. And so what we end up doing now is we end up making, I think it says, calcium phosphate and sodium chloride. So calcium is Ca, it's still +2. PO4 is phosphate and it's -3. Well, between these two, 6 again is the common thing. So we need 3 calciums +2, +2, +2 for the 2 -3 phosphates. -6, +6, and they cancel. That's how you properly write the formula for calcium phosphate. And sodium chloride. Well, Na +1, Cl -1. You get rid of your charges just to be thorough. All right, so now we got a balance. Well, I look at this and I say, okay, what doesn't add up? Now, I'm going to do this one wrong on purpose because I want to show you something. So at first you might say you have 3 sodiums, right? So you try 3 right here, and you get 3 sodiums. But that also gives me 3 chlorines, doesn't it? Is there any number that's a whole number, because you can only use whole numbers, times 2 that gives you 3? Nope, there isn't, because 1.5 times 2 does not exist. You can't put fractions here. So I know this 3 is not right. So I found myself saying, okay, well, then let's try this another way. And you know, guys, get a good pencil, because balancing can be intense. So I said to myself, okay, well what if I tried the calciums? I have 3 calciums there, I tried 3 calciums there, right? That also gives me 6 chlorines, 3 times 2. Well, if I put a 6 right here, that gives me 6 chlorines, but it also gives me 6 sodiums. Well, what I can do here is I can put a 2 right there, 2 times 3 is 6 sodiums. That also gives me 2 PO4s. If I can, I keep it together. Well, good, because PO4 is over here, and there are 2 of them. So, here we go, 6 NAs, 6 NAs. 2 PO4s, 2 PO4s. 3 CAs, 3 CAs. 6 chlorines, 6 chlorines, and it is indeed a balanced chemical equation. And that is 1 through 3 on the first page for word equations.